Alright, so I'm going to do a video on how to do a registration cloud to cloud. So the first thing I want to show, here's all my stations that came in. Let's open up a model space and take a look at where the station is. So click on that, we got 0, 0, 0. Alright, let's go to station 2. Alright, we'll click on this station. Same thing, 0, 0, 0. So this is going to be the same for stations 3, 4, and 5. As long as you're doing free station scanning in the field, each station's going to come in at 0, 0, 0. So let's say I was going to make a registration and open these scans just how they came in. All right, I'm just going to add these in to my scan world, and then we're going to open them up, take a look. Right, you just have a big mess because all the stations are going to line up at 0, 0, 0. And this is basically what we're going to sort out in cloud to cloud. Okay, so let's start over from scratch. So let's create a registration, open it up. We'll go to add scan worlds. We're just going to do a couple stations first. Hit OK. And you're going to select these two. Go to visual registration and go to 2D scan thumbnails. So this one we'll do in red. This one we'll do in blue. All right, and then we'll open in visual alignment. When you do this, Cyclone's actually going to pop them together for you, but for purpose of the demonstration, we'll hit this R button, which will separate the scans how they originally came in. So now what we're going to want to do is align the scans by basically translating and rotating one scan on top of the other. So right now, I've got scan 1 and 2 in red and blue. So right now 2 is the one that I'll be moving. And to translate, you'll hit this button here. And I just like to kind of pull the scans apart. Okay, I'm going to rotate now, just by clicking the rotate button and then pulling away from the point I clicked from and moving the mouse. So I'll get that one nice and straight. Now I'll click 2, this one oriented the same way, maybe a little bit more. All right, now we'll get into the fine tuning. So I'll stack these two together and I'm going to look for a good rotation point, probably something over in a corner. So let's take a closer look. I can tell this area and this area are common features. So I'm going to move those corners together. Then I'll rotate from this point and get these to line up. All right, now let's take a view higher up and let's focus in on this area, still rotating from this point. All right, so if I want to slow down my rotation so that I have more control of it, I can hold down Alt, and you can see now it's moving much more slowly. But I'm just going to kind of take a look, and when those look like they're lining up, I'm then going to go back and tighten it up. Look further down. Looks like it's pretty close. You don't have to get it perfect. That's about as close as I want to get looking from the top down view. Now I want to go to my elevation viewport. All right, so we'll go into viewport, elevation view, the hand tool, zoom in. Now I can tell right there that these are not lined up, so I'll pick these up and down arrows and I'll get pretty close. You only need to really get within an inch for this to work well, so don't get too particular with it. All right, so now that we have everything lined up, We'll go to optimize constraints, and this is going to basically run a bunch of calculations to fit these two scans as tightly together as possible. It's going to perfect the alignment. And you really want this little histogram to look like this, where everything's nice and tight in the corner. All right, so now we have our results. So it overlapped 910,000 points. We've got a root mean square error of 0.026. That's pretty high. Average error of just 15 thousandths. So why do we have such a big error here? Everything here is nice and tight. The problem is we have a lot of moving objects in the scans, all this vegetation over here. So it's computing the overlap of our stable objects and also all the objects moving, like all of our vegetation. So that's why we're getting a larger error from those moving objects. So let's go ahead and go back and get the rest of this registered. Go back to my registration. Now I could have added all the scan worlds at once. I was just simplifying it to show you just putting two together. Let's go ahead and complete registration. So group 1, those are stations 1 and 2. Ungrouped, I need to now cloud to cloud 3 with these groups. So we don't have to use the thumbnails. So let me show you. You could also just pick, station 3 against station 2. It's like visual alignment. All right. Now I already showed you to align those. Looks like these came in aligned. We'll just take a quick peek at the vertical. We'll use this over here. Oh, looks like the vertical's still off. All right. Again, we'll go to optimize. Make sure your errors are acceptable and then hit yes. So that'll become part of group 1. We'll have now stations 1, 2, and 3, and then 4 and 5 in the end group. So I'll just rinse and repeat and kind of skip to the final process after I register 4 and 5 into group 1. So now we have all of our scan stations 1 through 5 in one group. That's what we want to see. So now I'll select group 1, go to auto update. We'll see our errors between each scan. We can then go to create scan world, freeze registration, create an open model space. So now we can take a look at our model space, see how all of our scans came together. As you can see, this one looks pretty good. So that's how you do cloud-to-cloud registration using visual alignment.